Hey everyone, thanks for joining our session. So today we are going to talk about streaming processing for the RAG architectures. So quick agenda topics. So we are just going to talk about a very lightweight introduction for RAG and why we are using streaming for RAG. And then we are just going to talk about like how we leverage Beam for RAG and example tech stack. So we have like an example use case that we're going to talk about. And we are going to talk about Beam transforms and then demo and then Q&A. All right, so very quickly on RAG. So RAG is retrieval augmented generation. It's an approach to extract the information from the data that is not being used in the training of LLM. So if you want to augment your data, augment your LLM with new information, this is the way to go. So RAG has two main parts. One is retrieval augmentation, and the second one is generation. So let's talk about the generation part. So this part generates the responses for the user based on the parameters that LLM is originally trained on. So these models can have some undesirable behavior. For example, if your LLM is not trained on a specific data source, the response can be very random or no response. And the second, if your information is outdated, the response can be incorrect. So what happens when we add a retrieval augmented part? So instead of relying what LLM knows, we are adding content store. So this content store can be open as like internet, like leveraging news or tweets and so on, or it can be closed like documents, PDF, presentation, and so on. So with this approach, user query will go to the content store first and look for the relevant information and send the response back to the user. So now quickly talk about like the RAG pipeline. So RAG pipeline has three main parts. So first part is data ingestion. So in this part, we ingest the data from various sources, like the open sources, like maybe news or tweets, or like the other sources like documents or PDFs, etc. So with the use of embedding model, it chunks the data into smaller chunks and store the data into vector databases along with the content indexes. And for the query retrieval part, when user asks a question, it will go to the content store, look for the relevant information, and in case of answer generation, it combines the result with the LLM and return the response back. All right, so why we are using streaming for RAG? So like events occur in real time, news change in real time, our documents being updated in the real time. So we need to enrich the model with the real time, in the real time fashion. So traditional RAG pipeline often rely on the pre-processed data and pre-processed indexes, so which can become like outdated like very frequently, right? So we need a streaming pipeline for the continuous data ingestion and continuous data processing to ensure our RAG is up to date. They have like information accessing is just like very real time. And the other factor is like the scalability, because we are handling like large volume of data and we need to make sure our real time and near real time applications are efficient enough. So now over to Pablo.
Right. So the idea is to, of course, use Beam in this case, right? Why we use Beam here is because we have a bunch of lots of connectors that uses I/O for streaming sources and destinations, right? We have really good primitives on Beam that help us to support really high throughput use cases, right? So we can do windowing, we can do triggering, we can tune our pipelines to just go for completeness, we go for latency, we go for cost improvements or optimizations. So Beam is feels like the right language, and the primitives are very good on describing that behavior that we need from the pipeline. It also supports multi-languages. So the majority of the data prep stages, the interactions with models currently are done in Python, right? Maybe in the future it's another language, but large majority of our I/O implementations in Beam are done in Java. So it's a really good way to integrate both worlds, and where we care about performance of data retrieval and storage and also processing data prep. There is a lot of front-end flexibility as well, because we have multiple runners. We can use Dataflow, we can use Flink, we can use Spark, we can use Prism, we can use whatever that is available. So it's really good options in there. And also it's very important about the unified programming model. It's pretty frequent that in cases where we process data once and we get that working for our models, new LLM APIs appears, new versions of model appear, we need to reprocess everything again. So everything we may have been doing on streaming fashion to process and store the data, we may need to do that again in batch, right? We need to fine tune the model. We need to do stuff with that. So Beam is the right way of doing it because you just write your logic once and you change the sources and sinks. Well, the sinks in this case will be the same, but the sources may be different and you can have the same pipeline taking care of both worlds. So we come up with a specific use case. The main idea of this was last year we had a hackathon where we had to take care of content updates from many sources, documents and stuff, but it can be expanded pretty easily to other things, right? That there is, as Namita mentioned, there are world-changing events that are happening every day, right? There are social events that are around the world happening, sport events, news, election results, stuff like that, for what a model that has been trained maybe 2 months, a year ago, that's not prepared to answer questions about. So we can use a RAG architecture in that case based on streaming ingestion to enrich the model context and get accurate answers, right? So of course, since this is a streaming type of use case, we care about data freshness, we care about consistency and data validation. We need to cross-references the things we are ingesting with the content that we are providing as answers. We need to keep low latency and be ready for changes on throughput, right? That is something that we do not control in the streaming world, and where we don't know when data will end up, coming in, or we don't know the, volume at, the very beginning. So using Beam in this case is very helpful. We can do back pressure on the window in a triggering system, so we can just use the data that we, can process at a moment in time. So the example pipeline we have is, as I mentioned, streaming, right? It's very small over there. We're going to share the slides so you can later on, zoom in. The implementation that we provide as an example also is based on Google Cloud Technologies. Getting ready for the question about why don't use Beam for also serving the query path. I tried to do that later yesterday after the session, but I wasn't, able to make it work. But we have a Cloud Run runtime that will take care of that. But Beam could totally be a feasible thing to use to do asynchronous queries, right? If you put a service and you just want to get an answer to a PubSub topic or some Kafka topic or streaming infrastructure, you can do that as well. But in this case, we are using a streaming source PubSub. We have components that takes care of data abstraction, embedding, creation, and indexing that embedding in some vector database. We have a storage destination for the content that we extract from the documents and sources that we ingest, and interactions, as I said, with vector databases and large throughput storage, because later on we may want to fine-tune the model, right? So what is there as a tech stack in this case? We are using PubSub, we are using Apache Beam, of course, running in Dataflow. We have Bigtable as our content store for low latency. We have interactions with models through the Vertex AI APIs. And that's actually pretty good because we can switch models pretty quickly if we need be. We use GCS for the content that we extract and Cloud Run as a service layer. There is a link there on a GitHub repository that you can take a look at the code that we're going to present. There is also infrastructure automation there, so it's somewhat easy to get it working if you need to test out things and try it out. From Beam perspective, what we have is, as I said, PubSub IO interactions are controlled with that. We have a bunch of custom DFNs that runs as Pardue for data extraction for the different type of sources that we are supporting in this case. This is a Java pipeline, so we have a register 4-inch code that runs in Python. So we have the Python external transform integration there. We have Bigtable and TextIO for the content that we store in GCS. Now let's get to a demo very quickly. Here it is. So this is the pipeline that we have put together. This is a Dataflow pipeline, which contains the transform. For some reason, it's rendering really weird, but this is the ingestion, which takes URLs as inputs of the documents or content that needs to be ingested. We are doing some window logic over there, and we extract data from documents. We have, of course, content extraction and error handling over there. In the cases of error happening, we can decide if we retry or not, given the error that we capture. In the case of retries, because we interact with some content API like Google Docs that doesn't have a high API quotas or limits that we need to take care of, so we need to retry that afterwards. After handling, we extract the content, as I mentioned, and we store it as JSON-L format in GCS. This is good for fine-tuning on models, right? And then we have the prep content phase. We have a consolidation, which is a reshuffle. We could have used some consistent input tagging on the DoFM, but we did it manually here, but should get the same result. We have the external interactions that for some reason is rendering on the side, but this is the same transform that interacts with the model APIs, right? This is where the LLM magic and embedding happens. Then we just grab the embeddings and store them, as I mentioned, in the index database, which is our vector database in GCP, and then Bigtable. And in the case of content updates, because we are chunking in a consistent manner, if the document changes, we may get different chunking afterwards. So we probably will need to remove data from the content that was stored and indexed. Afterwards, we receive updates from the document. So the other thing that I have to show is I actually care about sports a lot. So we use a model for this demo that was trained on 2020. So there's a lot of information that happened on current events that is not present on the model, right? So we can ask them questions. In this case, I'm just creating a very dumb document that actually was held by some LLM to be redacted that talks about what happened on the gold medal game, the USA basketball team, right? So it's something there that talks about what happened on that game, right? So let's say that I can interact with this thingy. So these are queries that we are sending to our solution, which basically, in this case, as you can see here, what happened in the gold game on the last Olympics? And the answer is basically the US States men's basketball team won the gold medal in 2020, right? So after we ingested the document that I showcased some moments ago, we send the same query and we get better information regarding the results of the game. And another thing that is important is that we are actually cross-referencing data, right? So given that we control the storage of not only the embeddings, we control the storage of the documents from where we extract the content, we can say from where that information is coming from. And this is very important, right, for safety purposes on the content that we are delivering to customers. So thank you. This is all we have. There is some information on LinkedIn over there. And if you need to get a little bit more of deeper insight of what the pipeline actually does, we wrote a blog post last year, so take it a read. Thank you.
Thank you.